All right, so welcome. Let's begin. Welcome to this webinar. Let's begin with this session of today. Let's begin with this webinar related to shells, okay? Shells in Cype 3D. We'll be talking a little bit about this topic during the next 45 minutes to 1 hour, okay? So shells in Cype 3D, introduction, design, types, and examples, okay? Thank you very much for all of you that came today. Thank you for your attention. It's a pleasure to be here sharing with you a little bit about these tools that we have in our software. Okay, so let's begin with this section. My name is Afonso Solac. I'm civil engineer and I work as a marketing director here at Cype. I will be your host today. Will be explaining a little bit this topic to you during this journey. So welcome again. Thank you very much. Just before we start actually with this presentation, let me just share with you some contact options that you have if you wanna interact with us. Okay, so we are transmitting this seminar in different places, in different platforms. So we are now transmitting it on LinkedIn, on Facebook, and also using the GoToWebinar option. Okay, so if you are watching in these platforms, you have options to both leave comments on the social media platforms or also in the GoToWebinar platform. For those that are watching us from LinkedIn and Facebook, I really recommend you to switch to GoToWebinar. There's a link here below in the description and also in the comments in both platforms, because the transmission there is a little bit more, the quality is a little bit better, and you have also some extra options to send messages to us and also to see the links that we are sharing. Okay, so if you are on LinkedIn or Facebook, I really recommend you to use this link that is in the section below. Okay, and if you are watching us after this presentation, if you are watching the recording of this presentation using our YouTube channel, you can also send in from your questions to us using our email option, cype@cype.com, or even using the contact form that we have in our website, that is cype.com. Okay, please feel free to comment, feel free to share your doubts or your suggestions, that we will be very happy to know it. Okay, so today we'll be talking about a lot about Cype 3D. Cype 3D is one of the softwares that we have in our group of softwares for structural analysis. Okay, it's a part of a suite, a part of a toolbox, let's say. So usually we situate this software in the middle of our workflow. So before the software, we have one software called Portal Frame Generator, and after we have two other softwares that are called Cype Connect and Strubing Steel. And today we'll be talking about a specific part of Cype 3D, this part that is related to shells. Okay, remembering that you can use our softwares combined, as you can see in this workflow here, but you can also use it separately. You don't have to have all these softwares in your license to use it. You can use them separately. That is going to be the case that we will see today in this case of Cype 3D, but you can also combine it and reach some more powerful aspects of this combination of softwares, and then you can add these different softwares to your license, increasing these options available. Okay, just to show some examples about Cype 3D, some of the structures that we can do with the softwares. We can cover different materials, different type of structures. Okay, even shell structures, as you can see in this little example that you can see here. That is this spheric deposit that you can see here, that is made not just by bars but also covering shells. Okay, so the idea of today is introduce this concept to you, show the main features related to shells at Cype 3D. Okay, unfortunately we don't have too many time to see all the aspects, all the theoretical aspects related to the shell analysis, I'll try to show the main ones and more specifically the options that we have in the software to model, to analyze, to describe these shells using the different menus and buttons that we have in the software. I will also share with you some examples that are quite nice too. Okay. Let's go. So just before we start, just remembering that here in our website Cype.com, you can find more information about Cype 3D. Here in the solutions menu, you can navigate through the solutions for professionals option. And here in this case that we are talking about structures, you find more information about Cype 3D. Okay, so Cype 3D is here. I'm also sharing this link with you in the chat. And here you can find more information about the software. You can find learning resources, and you can also download the software. Okay, you can download the software to update your version if you're already a user of the software, or even to try the trial version that is available for 10 days. If you wanna try the software, just use this button and download the software and start working with it. Okay, here in the learning resources, I think it's a good place to start understanding how the software works, and I really recommend you to use this option here, the quick start guide, where you can find more or less 30 different lessons that are quite a good way to start understanding, start working with the software. Not just this part of shells that we'll be discussing today, but all the other aspects of the software. Okay, I'll also link this. I will leave this link on the description. Okay, so let's start. Let's open Cype 3D. Actually, here I have the Cype menu. The Cype menu is the place where we have all the softwares of Cype. I already have this software installed on my computer. I can also filter here. Those that are on grayscale are not installed in my computer yet. Cype 3D is already installed, so let's open Cype 3D here. And let's start talking a little bit about the software and looking for the options that we have here. Okay. Before we really start looking how to develop these models, let me show some examples that are structures made with shells that can be created here at Cype 3D. Okay. For example, this is a quite nice industrial element, industrial equipment that was made by shells that can be analyzed here at Cype 3D. Or let me open another example here. For example, like the deposit that we saw in the PowerPoint presentation before, that is can also be developed here at Cype 3D. This is a structure that is mixed. We have some bars, some elements that are bars, but we can also see these little shells that were combined here to create this spheric deposit. So you can see that we can combine bars and shells in a same model. There is no problem. Okay, so you can combine these two types of structural elements. Let's open some other examples here that I've prepared before, like this one here. That is again an example combining bars and shells. This is a kind of funnel for also a structural element. Okay, let's open a little bit one more. For example, this pedestrian bridge, like that is a model where we can see there are some bars and also some shells that in this case are simulating the reinforced concrete slabs of this little bridge. Here with this system we can activate and deactivate these elements. Actually, if I deactivate here, the shells are actually these elements here. Okay, so as you can see here, we can combine these elements. Okay, let me open one more example. For example, this one here, I think it's a quite interesting one. That is an arc bridge. Okay, this bridge was created with different shells again. We can see here that the shells were introduced here. For example, the purple lines. Let me just change it for a more schematic view. You can see that each one of these elements, these planes here, we also can see there are actually shells, and these shells were introduced in a way that we can, when combined, they are part of an arc. Okay, so actually here we have the arc itself here. Okay, we also have the beams, creating this nice section here, this specific geometry for a bridge, for example. And here we can also see this blue area that is the top of the bridge. And in the unique part of this model that are not shells are those columns that were introduced as bars. Okay, we can see when we change for this schematic view of the project, we can see that they are actually bars and not shells. As I said before, you can combine different types of structural elements with these shells. Okay, just remembering that Cype 3D, it's a software where we can design the structure, but we can also design the foundations. We will not cover this part of the software today. There are other videos and webinars available in our website where you can find more information about foundations, but just remembering that you can also do that kind of analysis here at Cype 3D too. Okay, so let's go. I will open, we'll come back to these examples in a while. We will navigate in different situations, and in these examples they will appear again during this presentation. Okay, but I will start creating a new project here just to introduce to you the main interface of Cype 3D. Of course, I will not cover all the aspects here, but I'll try to focus on those that are related to shells. But as we just updated the software like 3 or 4 weeks ago with some new elements in the interface, I will try also to show these new elements that I think they will be very useful to you. So the first thing that happens when we open the software, it's open this menu where it's the general data of the project. Here we can select the different codes for the different types of materials and structures that we will have in the project. We have different codes for concrete elements, cold formed steel, rolled steel, timber, or aluminium. And here we will actually set the parameters for the materials. So the type of steel, the type of the loads, we can create the load cases here. Here we can also define the materials for the reinforced concrete elements, or even define information related to the foundations. All the information that is defined here, we can then come back and change it if we want. And for those situations that we are talking about materials, all the elements that we introduce then in the structure in the future will be by default the values that we introduce here. And then if we want, we can specifically change one of the elements for a different material if you want. But if we don't change, the material by default will be the material that is defined here. Okay, here just opening the software, we'll open the main interface of Cype 3D. It's the name is Cype 3D because actually we are working in a 3D environment. So here in the right side of the software we have the area where we will create our models. Okay, here we have different tools that can help us to snap elements. We can use orthogonality. We can introduce elements according to a distance that we will enter with the keyboard. Okay, different options that are related to the modeling part of our project. Here you can also see that my name is here because I'm connected to the cloud. I'm connecting with the BIMserver.center platform. So this is a software that uses the BIM technology, so we can export and import elements from BIM models from Cype 3D and to Cype 3D. So we can create a model here and export it to IFC, for example. Again, this is not part of the presentation of today, but I think it's important to know. And here in this area, in this vertical bar, we have different options to set the visibility of the elements that will be modeled here in this area. Okay, in the top we have the main menu of the software. Here we can change properties related to the file, the project. We can also introduce the nodes, the bars, the shells that we'll be exploring a lot today, and also some other options that are available here. Okay, let me open another one of the examples that we saw before, just to have a interface a little bit more complete with more options available, just because the project it's a little bit it's a little bit advanced. So for example, this guide that we saw before, to model this this software, we used these references here, okay, these tags, these layers, let's say that. So we have this system to create layers. We can create these layers here, okay, and then according to the moment that we are modeling, we can activate and deactivate these elements. So if you have a complex design, a complex geometry, you can create your layers here and then activate and deactivate according to the needs of your modeling phase, okay? These layers, we can change the position of it. We can use this button to select something and assign a different layer if we want. And we can also use this part here that is a filter that is by categories. So in an element, in a project, we can have bars, ties, columns, beams, panels, and shells. And for example, I can deactivate here all the shells. Actually, this project is made just by shells. So if I deactivate, I deactivate everything. But in a case where we had panels or beams or columns, we could deactivate just the columns or just the ties or just the beams of the project. So it's another way. It's the same situation that we have here, but in this case, based on categories. Okay. There are some other tools here that are quite nice. So we can activate this option to represent the structure using the colors of the layers, or just using the default color that is green in this case. We'll see in a while that we can have a buckling analysis of the shells. We can also display the elements that are part of the buckling analysis, okay? We can also, when we hover with our mouse in the elements, we can display the element information or not, okay? So as you can see, each one of these shells, when I hover the mouse, I can see the properties of these shells and other options that are available here, okay? So cool, yeah, I think these are the main aspects of the interface that we must know before we start modeling a shell here at Cype 3D. So let's open a new project again, and let's start modeling something here to know how it works, okay? So if you use the shift button of your keyboard and also the mouse, you can orbit like this, okay? And just with your mouse, you can pan like this, okay? Here we have the coordinated system. And in this case that we are talking about shells, let's jump to the shells menu, okay? So we can create a new shell by clicking in the new option, and this shell have some properties. And here we start understanding how the shells work here at Cype 3D, okay? The first thing that we can do here is decide what is the thickness of this shell. For example, we'll combine it with this information related to the material, so we can create thin plates for rolled steel, or even simulate concrete slabs, for example. I will start creating here a little slab of 30 centimeters, 300 millimeters. We can also decide if this shell will be in contact with the terrain, and then we will have a subgrade modulus to this shell if you want. The behavior could be linear or only compression in these cases. I will start with something simple. And as I said before, according to the selection that we have here, you see different materials that are available here. So the material selected on the general data option that we saw before, or I can personalize and select a different material to the element I'm modeling now. So I'll select a concrete element here, for example. I'll use the material from the general properties, and then I can start modeling. I can click. As you can see, I just use my mouse to decide the position of the one of the sides of this slab, okay? And when I click, I can decide the size, for example, 10 meters. If I activate here the orthogonality, it's going to be more precise. You can see that it's locked for one of the directions. So for example, here, let's imagine that is 4 meters, and then here 10 meters. To create a shell, we need a minimum of 3 points that are coplanar points. So actually here in this situation, I'm creating a shell that is rectangle, but actually to create a shell, we don't need, we need at least three points. Okay, so as you can see here, this is one of my shells. Okay, I can snap these points, remembering you have this option here to activate or deactivate the object snap and add more shells. For example, let's add another one, I don't know, 3 meters, for example, also with 10 meters, and like this. Okay, and here we have 2 shells that are connected, or actually they are not yet connected. I'm show to you then the fixities in a while, but they are modeled. Okay, and as you can see, we have here some symbols that show to us the local axis, the local coordinated system of each one of the shells. So besides the general or the global coordinated systems of the project, we also have for each one of the shells a specific coordinated system. Okay, this coordinate systems, it's the direction of the red axis. It means the x axis, sorry, it's gonna be the direction of the first line that we introduce in the shell. So I have the first point. When I introduce the second point, when I finish that, you see that the red one, let me deactivate this information here, the red one was the same direction of the first line that I've introduced it. Okay, so as you saw, with 3 points I can create my shells, and the red one, it's gonna be the X direction. Okay, let me delete this little triangle here. So as you can see here that I have shells modeled, I have a lot of options available. We will cover this shells, these options in a while. So let me delete this little guy here, and I see here some nodes that were created automatically. So I will delete these guys here because we don't need it. Okay, so coming back here to the shells menu, if we have this X in the red direction, we can change these directions if you want. Okay, so we have here some options to reverse the direction of the Z-axis or the X-axis. Okay, so starting with the red one, if I click, for example, here, as you can see, the red X changed and it's parallel to this direction here. If I click here, in that direction. If I click here, in that direction. So I can select which is the direction of the red X. Okay, but if you see the blue one, that's going to be the ZX, it's always in the same direction. Okay, I just change the red and the green, X and Y, but the blue, it's always in the same direction. If I do here the same situation, it's gonna be the blue, it's always in the same direction, but we are changing just the red and the green. Okay, to change the blue direction, we have another option here that is reverse the direction of the ZX, and then we can change like this. Okay, so why this is important? It's important because there are 2 main points, 2 main aspects that are important here. The first thing is, in a second moment, we use these options here to introduce loads to these shells. And those loads, they can be introduced according to the local coordinated system or the global coordinated system of the project. Okay, so we must know the direction of the axis because then the direction of the loads, they could be according to these directions here. Okay, so this is one aspect that is very important. And a second aspect that is very important is related to the way that the results, when we finish the analysis, we'll see the results, and then we must see these results according to the local axis. So it's convenient to have the locations in a way that we can understand those results later. Okay, so if you have many shells together, it's going to be better if you have the same local convention, because then the results in a specific directions, they will be easier to understand. Okay, we'll see some examples in a while. Okay. All right, another aspect that we must know about the shells here at Cype 3D related to the modeling of a shell is that we can join or divide shells. Okay, so for example, I'll grab here the middle of this shell, and I can divide one shell in two parts. For example, here I'll do the same. I will do here in the middle of the middle, so in a quarter. Okay, as you can see, for each one of the new shells, now we have a new coordinated system. Okay, as you can see, we have some complementary lines here. These orange or brown lines here, they are just reference lines that can be used to be snapped or to help us to model something. We can activate these references here in the planes references options. So we have here option to set how to display. Just to have a cleaner interface, I will deactivate everything, and then you can see just the shells of our project. Okay. Those options to join and divide, for example, to divide, we can also create something if we deactivate the orthogonality, something like this, or even crossing elements like this, there is no problem, or doing something like this. Okay. So you can create the combination that you want to divide the shells according to the preferences or according to the project that you have. To join elements, to join shells, it's quite the same situation. You click in one element, in the other, and then you can join these elements like this. Okay, so you can start creating. The only thing that you cannot do here is to have openings in a shell. A shell must be a closed surface, okay, at minimum 3 points, of course, and you cannot have openings inside of a shell. To create, for example, a ring of something, you must have two semicircular shells and then connect them with a specific fixity that we'll see in a while to have this ring, for example. Okay, cool. So now we know how to model a shell in a manual way. Then we'll see more options. Let me join everything here just to have a good situation again. For example, here, let me model everything. We have some nodes that were automatically created here. So let's delete these nodes because actually we don't need these isolated nodes now. This one, this one, this one, this one, this one. Okay, so we have a cleaner project. So this one we don't need. So just the main nodes of the project. And now that we know how to introduce the shells in a manually way, let me show you a second option. I will save this project. We'll come back here to this example, but let me open a new Cype 3D section here, and let me show you two options that can easily that you can use to easily model something here at Cype 3D. I will come back to the spheric model that we saw before. This model, if we deactivate the 3D representation of the elements, is actually this situation. And as you can see, it's quite similar to a CAD file, a DWG or a DXF file. Actually, these layers, they could be compared to layers from AutoCAD, for example. And actually, that's the way that this model was created. Because here in the tools option, we can import DXF and DWG files, okay? And let me go here to my folder here, in my shells here. Let's change to DWG, and here I have a model that I can import from AutoCAD, for example, or any DWG file. And the layers of the project, we can select if we want import or not these layers, the geometry of these layers. And when we import it, for each one of the layers that we have here, a new layer will be created here. And then we can associate for each one of these layers different structural elements. For example, we can deactivate everything, maintain just, for example, the sphere layer, okay, and then select everything and assign a specific type of shells. And then we can do the same situation with the elements that will be part of the stairs, or the elements that are part of the columns, and so on. So you can use these DWG files to import elements, and remember that those elements that are surfaces in your DWG file, they can be converted to shells here at Cype 3D. So it's a nice and easy way to create nice geometries or complex geometries here in the software. Another situation that I think it's quite nice for Cype users is that if you can use also Cype architecture, that is our free 3D modeler for BIM modeling. So there are some options available here at Cype architecture that can be used to transform the geometry created at Cype architecture into structures made by shells or other elements at Cype 3D. Okay, for example, let me show the same example that we saw before, that is a bridge here in the 3D modeler, in this case Cype architecture. Okay, as you can see here, this is Cype architecture, is the same model here, and the elements that are here, the sketches that we can create here, we can develop these elements here. So this is the sketch that I used to create my BIM model. When I export, when I share these elements with BIMserver.center, I can generate a DWG file with these lines and surfaces. And if we come back here to Cype 3D, let me open the same project again. I use it in this case the elements to create here the shells of my structure from the DWG file that was imported as a DWG or DXF file. And the point here that is nice is that everything that is well connected, so the position of the elements are exactly the same positions from the BIM model that was developed in the previous software. And actually we can also see it here in the 3D view of the complete structure, not just the elements that we are modeling here at Cype 3D, but also the elements that we imported. For example, if I deactivate everything that was created here at Cype 3D, I can see those sketches that were imported from Cype architecture in this case. Okay, so if you don't have a 3D modeler, if you don't have a software to create the geometry of your building, just look for the Cype architecture in Cype menu, that is for free, and then you can send these 3D elements to Cype 3D and then design the elements, including shells. Okay. All right, so we saw some general details from the interface of Cype 3D. Let me check here the time that we have and also the topics. We saw also that we can we saw the layer systems. We saw how to the modeling environment. Just let's come back a little moment here to our recent project that was the empty file. Let me see here. It's here, and let's keep looking for some details related to shells here. One thing that is important here is describe the material and the section of these shells. So with this option here, describe section, we can change the properties, the geometrical properties of a shell. In this case, I've selected a thickness of 300 millimeters, and I didn't introduce the subgrade modulus in this shell. I could change this parameter using this option here. Okay. Here we can also describe the material. If we selected one material, here we can change, and we can do some different types of materials here. We can simulate concrete slabs or concrete walls or concrete shells using this option here. We can also introduce rolled steel plates or rolled steel shells, cold format steel, even extruded aluminium, okay? And we can also create our own material that could be isotropic or orthotropic. Okay, isotropic, we have the same, let's say the same resistance or the same mechanical properties of the material in all the directions of the material. So the same modulus of elasticity, the same thermal coefficient of thermal expansion, okay? But in some situations, like the CLT panels on wood panels, we can have different mechanical properties according to the material or the direction of the grain of the material. That's very common on wood elements. So then we have an orthotropic material, and here you can also introduce the information for two different directions, X and Y, for this material. Okay, so if you are looking for a software to design shells with orthotropic materials, you can use Cype 3D for that purpose too. Okay, and using this little button here, this blue arrow, we have an assistant specific for CLT panel. CLT, it's one of the specific case of an orthotropic material. So here you can introduce, get this information for a manufacturer of CLT panels and introduce these properties here according to the direction of the fibers of the boards. Or for example, we have here for modulus of elasticity or shear modulus in the direction that is parallel or perpendicular to the fibers, okay? And also the density of the material. When we select one of these elements here, the properties will change here, okay? And then we can assign these properties to the shell itself, okay? Just to show you one little example, if I go to my 3D view now, I've introduced a concrete element. I can see here the concrete structure. Let's see here the concrete structure.
Não há nada para continuar.
Oh, sorry, I have my Alexa talking with me here. No, I'm sorry. So the concrete structure here, okay? If I go to my shells option and, describe the material, I can change it for a code format A36 steel, and also I'll change, for example, the section to something a little bit smaller than that, like, I don't know, 20 millimeters, 2 centimeters, and I can see here in the 3D view this change, okay? Okay, just to show a little example how it works. Let me come back. Here we have the concrete again, and let's see more details related to the shells here. So another information that is important here is the option to describe the internal and external fixity of these shells, okay? These shells, let's begin with the external fixity. They must be connected to some element that is connected to the base, the terrain, it's connected to an external place. We can connect the shell itself to the terrain, for example, or we can connect the shell to another element, like another shell or a bar, and then the bar or the other shell to the terrain, okay? So that's what we call the external fixity, okay? So I select here, I select the side of the shell that I want to connect. For example, I select the 4 shells, and then I set what's the external fixity of this shell. For example, fixed or pinned, or all the combinations that we can have here, okay? And we can also set if it's elastic or not, in which direction, and what happens with the rotationals. So we can set this external fixity to the elements. And the same situation is the connection between 2 or more shells. For example, if I open here the internal fixity option, I can select this line here, that is the connection between both of them, and set if it's going to be a free, a fixed, a pinned, or a generic internal fixity condition, where I can set the coefficients for each one of the situations here. For example, let's imagine here I have a fixed connection between these 2 shells, okay? Another option that I think it's important to show, it's related to the discretization of an element. By default, you will have a 1 meter square discretization. What it means? This rectangular shell will be divided in different finite elements that will be, in this case, triangles, okay? And these triangles will have a maximum size of 1 meter in this case. We can change these values. With a smaller size of these triangles, we will have a result that's going to be more precise, okay? So we have like 10 centimeters triangles or even smaller, but we also we need more time to analyze the structure. The analysis will be, will have more elements to calculate, okay? So here you can change these parameters. At this moment, I'll leave it in 1 meter, then it will change and we'll see some results, okay? Another element here that I think it's important, it's that we have some options here just to search for a shell. So here we have a shell that is S1 and a S2. If we have too many shells in our project, we can look for one of these, we can look for one specific shell. We just can search here and the shell will be highlighted in the project, okay? All right, so now we know how to introduce shells. We know that we can define the fixities, internal and external fixities. We saw how to introduce the properties of the materials, also the sections, and we also saw that it's possible to introduce geometries from outside of Cype 3D, importing DWG files. So let's jump for another part of this presentation. That would be the introduction of loads to these shells, okay? So these shells, to introduce a load, we have some options, and we use the load menu that it's available here, okay? So there are different options to introduce loads, okay? I will not cover everything here. Unfortunately, we don't have time to see everything, but there is one part that I think it's going to be the most useful for this case of the shells. That is the option to enter loads on shells, okay? So I'll click here, and now you see that some loads, this is just a yellow that is not too easy to see. You see that some loads are already applied here, okay? Loads, for example, this number here, 2.35 tons per square meter, it's the load related to the self-weight of these shells, okay? Actually, these loads, we can activate here the load. We have this option here that is the generation of the self-weight loads of the shells. We can activate or deactivate these loads. By default, the software generates the self-weight loads. So by default, this option is activated, but you can deactivate this option shell by shell if you want, okay? Usually it's easier to maintain it activated because the properties of the material, including the density, were previously defined. So if you just maintain it activated and you decide the correct size of the elements, the software will calculate to you the self-weight. So I really recommend you maintain it. But for a theoretical analysis, for example, maybe you can deactivate it, or any other type of analysis if you want, you can deactivate that. Another detail that we must know, that the loads that we introduce here, they will be classified in different load cases, and these load cases, they will be combined according to the strategy of applying loads that we have in our model, or even according to the different criteria from a code that we are we'll check the structure in the future. So here in the general data menu, in the loads, we can create more load cases, okay? So load cases that are related to the earthquake loading, fire resistance, limit states, additional load cases, those cases specifically for foundations or even construction process. In this case, I'll create a new load case just to show to you how it works. This load case could be the dead loads, live loads, shrinkage, wind, earthquake, snow, soil pressures. In this case, I'll just create one that's going to be a dead load, for example. I will add here a new load case, for example. Okay, we can add a description, and to these load cases, we will then assign different loads. Okay, in this project now I have the self-weight load case, and the new load case that was created. And when I introduce a load in a shell, okay, now I can select which load case I want to apply this load case. In this case, I will apply, for example, a load in this shell here that's going to be in the new load case. Okay, I'll select here, and as you can see, I have different type of loads that I can apply. I can apply uniform loads. Okay, I can apply this kind of variable loads in the local, remember, local x-axis. So x and y, you can see here, remembering x is the red and green is y. Okay, we can also, so here it's the same but in different directions. We can also add loads to do changes in the temperature, and also retraction. Okay, so we can add this kind of loads here. These loads, they can be introduced according to the local axis of the shell. Remember, now you can understand why it's important to set correctly these directions here, or even the global axis of the project. Okay, so let's imagine I would like to apply a load here, a variable load in this element that's gonna start, it's gonna be in the x direction. It's gonna start on 0.5 tons, and we'll start in 1 ton. And according to the blue X, I can set the direction of the load. So I would like to do something coming from here and going to this direction. So in the direction of the blue X, so it's gonna be this one here, okay, in the direction of the ZX. And if I apply, I can see that the load was applied here. Okay, of course, this is a very simple project, a very simple element, but here we have now all the conditions that we need, the minimum conditions to analyze this structure. We know the geometry, we know the fixities, we know the materials, and we have loads. This is the minimum that we need to analyze an element or analyze a structure made by shells here at Cype 3D. So if we have these options, let's jump to the analysis tab just to show you some little examples. I will calculate stress and strains to this little model that we've just created here. And as you saw, it was very fast because it's a very simple elements. And now here I have some options that are available with the results that we have for these shells. For example, the deformed shape of the structure. Okay, here we can have the deformed shape or the contour plots, for example. And for the contour plots, we have different kind of results. In this case, we can see the displacements, the total displacement. Okay, here we have this colorful bar here showing that the maximum displacement that we have, it was 0.03 millimeters. Okay, but we have other parameters. For example, the displacements in the x direction, in z direction, the rotational, and this is again why it's important to know the coordinate system, the local coordinate system of the shells. Okay, here we can also see the different results for the forces. For example, the axial in the x direction, or in the y direction, or in the combination, or the moments, for example, here. Okay, in the total shear, for example, different forces that we can see here. And of course, for each one of these forces here, we can see that the values here in the bar, they change. Okay, these colors, we can personalize it using these options here. There are different representation contour plots. For example, just to show to you here some examples, you can select that one that you prefer. Okay, and we can also set a minimum and a maximum value to filter. For example, looking for those critical situations, we can filter the minimum and the maximums that we see in the graphs. Okay, we can also see here the shear, for example. Yeah, all the forces that are that we have here to this little structure. Remembering that these forces, they are related to to the load cases. For example, this is just the shear on X for self-weight, but we also have the new load case that we've created, and the situation is totally different. And depending on the situation, we have combinations. For example, here in the concrete selection, we have the combination of those load cases according to the code that was selected before. Okay, looking here for the worst scenario here, for example. Okay, I think here would be nice to see some stresses. For example, the maximum stress, for example, here, or the von Mises stress, or the minimum stress. Okay, so here we have different results that we can see here. Okay, another thing that I think it's nice to see is that we can see the deformed shape. Okay, so if we click here, we can see, let me just activate the structure here, and we can see here the deformed shape is too small. Let's add a new scale here, and it's gonna be easier to see, as you can see here. Okay, the movement according to the loads that were applied. Here we can see that the fixity of the in the line of both between both shells. Okay, and the triangles that we talked before, we can see the elements that were automatically generated here. And that parameter that that we talked before, the discretization, if we add a smaller value there, we will have smaller triangles here. So the maximum size of one of these triangles, it's gonna be 1 meter in this case. But for example, as you can see here, we have smaller triangles to close this mesh, to generate the mesh. Okay, so yeah, this is how you can set these parameters. Okay, one thing that could be interesting. Okay, let's imagine here I would like to add a very just an example. I'll create some reinforced elements here. Okay, for example, like this. When I'm creating these guys here, okay, I'm adding I can set the fixity of these elements too. Okay, if I want, but I'm also can, if I want, I can divide the shells to have more precise analysis. Okay, so for example, I could separate here, creating one shell here, one shell here, one shell here, and here actually we'll have a line. And when the triangles of the discretization generates, we will have a line here, and not, it's going to be not the middle of a triangle here. So it's a good practice to create these lines here to generate a more precise mesh. Okay, so in this case, if we analyze again, let's see it. Let's see some results here. For example, the deformed shape. We will see that these triangles were all generated here, and we have a more precise result here. Okay, let's open one of those examples, like that bridge that we saw before. I think it was this one, just to see some nice results. I think I already analyzed it. Yes, it's already analyzed. So in this case, for example, as you can see, the contour plots, we can see the displacement here, based on the shells that were created. Okay, here we can see some of these results. Okay, let's add here just a little bit more of scale. Ooh, too much. Okay, and we can see also the structure here. Okay, so we can analyze the structure using these options here. Okay, remember, these results on the screen are to the selected combination that we have here. Okay, so here we have more combinations. Another option that I think it's interesting here, it's to see that we can combine the shells designed here in Cype 3D with another software that we have that is called CypeCAD. Okay, so CypeCAD, it's a software for the design of reinforced concrete structures, mostly for that, but we can integrate structures designed at Cype 3D at CypeCAD. And here I have a little project that was developed with CypeCAD where we have a cupola. It's a astronomic observatory. This one here that was developed with Cype 3D. So how it works here at CypeCAD, let me go just to the roof of the building here. We have this cupola here, but actually we can open Cype 3D through CypeCAD. So I can edit this cupola here, okay? And the cupola was modeled and analyzed here at Cype 3D. Now we have here the 3D environment or the 3D interface of Cype 3D with all the shells. And these shells, they have the loads were applied here. We can analyze the results here, okay, for all the combinations that we introduced. For example, in this case, I think it's a cold format steel. We have here, as you can see, a lot of combinations considering the different wind loads, the different directions, the seismic results, okay? And for each one of the results here, we can navigate through the results and see these results in the model, okay? So the thing is, you can design the shell structure here at Cype 3D and integrate this shell structure at CypeCAD. All those forces, those will be integrated into CypeCAD, and then you can finish the design at CypeCAD introducing other elements, okay? Just to show to you the end of this project, here in Cype architecture again, this BIM model have much more than the structural elements. So we also have other disciplines like the architectural model or even the installations of this project. So here we can see these elements integrated and also these shells that were created at Cype 3D. Let's see if it opens. Here you can see it, okay? Let's wait a little bit. The BIM model with the cupola that was designed at Cype 3D. If I deactivate everything that is the architectural model, you can see the structural model here, and this was the cupola that we saw before, okay? Unfortunately, we don't have too many time, but just to show to you one thing that I think it's important. Let me come back here to Cype 3D. One thing that I will leave a link here in the description to you, it's related to the integration strips. Although it's impossible to show everything here in this seminar, but the idea here is you can click in a shell, and then you can add strips, okay, to get the momentums, the shears, all the forces in this strip. Okay, so for example, I can create integration strips with 15 centimeters from here to here. Oh, sorry, it's gonna be somewhere like this. So the idea is to add these integration strips here to see these results. I will leave to you a video. Let's see if we have time here to see integration strips. You can get the results for this area and then decide the reinforcements, the rebars. For example, if we are talking about concrete elements, you can get these forces to then decide which is the best reinforcement to your structure. Okay, so here you can see the strips they created, and let's see if there is a part of the video that we can see where we can get these momentums. Okay, So this was the seminar for today. I know that was a lot of information, a lot of details. Actually, they are much more related to shells. I hope you enjoy it. Unfortunately, we don't have too many time to do everything that we really want. But if you have any doubt, feel free to contact us. Feel free to look for more information in these quick start guides that we have here in our website. And I really recommend you to try the software, download the trial version if you are not a user yet, because the software is very powerful and have a lot of interesting tools. Okay, thank you very much. See you in a next opportunity.